Good morning everyone. I am N. Tejashwini. I am from CSE department. Today I am going to present my topic on Newton's law of cooling. Introduction of Newton's law of cooling. Newton's law of cooling explains that how the temperature of a hot object decreases over time when placed in a cooler environment, which means when temperature is decreases, the heat of a hot body also decreases. It is widely used in physics, engineering, and daily life applications. Statement of the Newton's law of cooling. Newton's law of cooling states that the rate of loss of heat of a hot body is directly proportional to the difference between its temperature and the surrounding temperature. Formula for Newton's law of cooling. d by dt of T is equals to minus k into T minus Ts. Here why we take minus k means loss of temperature. Explanation of terms. T is equals to temperature of the object at a time t. Ts is equals to surrounding temperature. K is equals to cooling constant. T is equals to time. Derivation of Newton's law of cooling. Rate of cooling is directly proportional to temperature difference. d by dt of T is directly proportional to T minus Ts. d by dt of T is equals to minus k into T minus Ts. Here we have take minus k constant. Solving differential equation which gives T is equals to Ts plus T naught minus Ts into e power minus kt. Let us see one example problem. A hot object initially at 80 degrees is placed in a room with surrounding temperature 30 degrees centigrade. After 10 minutes, its temperature becomes 60 degrees centigrade. Let us see. Initial temperature T0 is equals to 80 degrees centigrade. Surrounding temperature 30 degrees centigrade. After 10 minutes, temperature is 60 degrees centigrade. Formula is T minus Ts is equals to T0 minus Ts into e power minus kt. Step 1. Substitute values in equation. T minus 30 is equals to 80 minus 30 into e power minus 0.051 into 20. T minus 30 is equals to 80 minus 30 means 50. 50 into e power minus 1.02. Step 2. Calculate the values. E power minus 1.02 is approximately equals to 0.36. T minus 30 is equals to 50 into 0.36. T minus 30 is equals to 18. Step 3. Final answer is T is equals to 30 plus 18. T is equals to 48 degrees centigrade. At 48 degrees centigrade, the temperature becomes 60 degrees centigrade. Here we have to see graph explanation of Newton's law of cooling. Shape of the curve. At starting it is increasing, at ending it is decreasing. The graph is an exponential decay curve. It starts from initial temperature. It continuously decreases with time. Steep at beginning, which means very high. At the start, the temperature difference is T minus Ts is large, so cooling is very fast. Graph shows that steep downward slope. On x-axis we have to take time, on y-axis we have to take temperature in centigrade. Gradually decreases. As time increases, temperature difference becomes smaller, cools slow down. Graph becomes less steep, which means flatter curve. Final stage equilibrium, which means balancing. The curve approaches surrounding temperature Ts. It never touches exactly but gives very close. This is called thermal equilibrium. Applications of Newton's law of cooling. Measuring temperature of hot objects. It is used to cooling of tea or coffee. It is used in industrial cooling systems. It is used in meteorology, cooling of Earth's surface. It is used in refrigerator design. Limitations of the Newton's law of cooling. It is not valid for large temperature differences. It is not accurate if surrounding temperature changes. it affected by air flow and surface area. Conclusion. Newton's law of cooling explains that how temperature decreases with time and shows that cooling follows an exponential law. It is widely used in science and engineering for analyzing heat transfer. Thank you.